We will start by presenting what is the actual deployment of a typical data center. We have them split through VLANs, which have their normal, already known problems. They are manual, they have some degree of inefficiency, they are low, they have low scalability, and they are always fragile because they depend on human interaction for this. So in order to address those concerns, a new standard comes to play. So we are talking about open flow. It's a centralized point of getting the whole solution deployed with a new standard on devices that support that, the open flow standard. It's just a means to have one central point of communication that will enable you to control the whole network, but as well, it brings new problems because you will have to create new updates to the devices that do not support this. There is a new standard involved that will create additional problems, and you can have additional failures on this. It will have to have control between all the network elements so that you can deploy a solution from end to end. Right, our proposed solution is a complete abstract overlay network that will be independent from the actual underlay. So we don't really care about what the fabric is. We can run in anything that is IP enabled. So what we are doing here is basically constructing tunnels between our virtual machines or any type of instance that I want to deploy in my virtual world. So I'll just create those tunnels end to end, and as I said before, they will not be aware of the underlay or the underlying protocols that are running on my IP network. Okay, so this is our solution. Contrail has 5 different types of components. We have the analytics, the configuration, and the control centralized. We have several view routers being deployed throughout all our compute nodes. And we will have our physical gateway, which is normally an MPLS and BGP enabled device. In this case, I'll be using the MX40. Okay, so we have 3 different types of nodes in the Contrail. These nodes are the configuration node, the controller node, and the compute node. For redundancy purpose, I built 2 controller nodes that will just perform an active redundancy setup, as well as for the compute nodes. The compute nodes, each compute node is a server that will run our virtual machines as well as one vRouter instance. The controller nodes will be an additional server that will provide us communication for BGP. And the configuration node will enable us to control all these elements in our setup, as well as gather analytics out of every type of element that we are running in our Contrail solution. The versions I'll be using, Precise Pangolin of Ubuntu, OpenStack Havana, and the current deployment of Juniper being 105. There is already a 1010 available, and we will be using that in a very near future. Grabbing that, what I said before, we have our MX gateway. This is one cluster, and this is my underlay network for that specific cluster. I have my 2 control nodes. They are running iBGP between them towards the gateway as well. I'll have my 2 compute nodes here. They are running the view routers, and they create MPLS over GRE tunnels between them and towards my gateway. The configuration node will be able to communicate to all these other servers using netconf. And the controllers will be able to communicate with my compute nodes using XMPP as instructions, not BGP as they do for the outside network and between them. Okay, so I have two clusters. They are running on their underlay network with these submaps to differentiate them. So one cluster 10.1.1/24 and the other cluster 20.1.2.2/24. The intercluster connections, so I have my both clusters connected to one another using two MXs and one eBGP connection. Why have I chosen this? Just because I want to provide the ability to do some service chaining using the MX. What type of service chaining can I do using the MXs? Just a simple instruction of providing internet access to my virtual machines in the networks that I would like to provide access to. So that's what we will be using and what I'll be showing. So each cluster runs its own autonomous system, 65.111, 65.222, and this is the overlay network that I'll be showing today. The purpose here is to have cluster number 1 serving as a workstation cluster and cluster number 2 serving as a service cluster. So this is where I have my server and one virtual firewall running. The workstations will provide me two clients, one being a client that is in the trust area, so I will allow every type of communications. And the Lava one is a restricted client, which I want to either disable or go through a firewall before I get access to my server. And the firewall I'll be running here is the Firefly instance. Let's go to our setup, and I'll be showing the Contrail GUI here. This is one of the clusters that I'm running. It is comprised with our two compute nodes, two control nodes, and the analytic and the configuration node, which is the one that we have access to. The same happens for the cluster number 2. I already have my water and my lava instances running here. So I'm just going to show them, the two of them active running on my Contrail. And this is the workstation cluster. For my service cluster, I have just one instance for the time being. That instance being the server. So I want to provide Lava the ability to communicate with my server using my firewall. So what I'll be doing here is to deploy one Firefly so that I enable this type of access. Right, how do I do that? I will use the Contrail solution to interact with OpenStack and the API Neutron to create a new network. I'll name this network as Firewall. I will associate a root target to this network because I'll be using that for BGP purpose. Grabbing my diagram, I know that my root target is this one. And I have created my network. I will assign an IPAM to it. What is the IPAM that I'll be using? It is this one right here that is used on Service Cluster 2 to communicate with the Lava network. It automatically enables my gateway, being the last IP of the last usable IP of the same subnet. So I'll create a new service template. The name of the service template will be Firewall. It will be running on service mode transparent. I can have it running on in-network or in-network NAT if I'm to provide some features additional to that network that I would like to run instead of being completely transparent, such as DDoS secure appliance that will just be able to filter what I'm going to do in my network and deploy a service in that same instance. Or I would probably using as well as an analyzer, and I can just say that using the service type menu. Right, the image name, I already have a firewall and a server name. That it's a pre-built image already configured for this type of deployment. I'll be using 3 interfaces according to my diagram. One interface facing the Lava network, one interface facing the server network, and one interface for my management network here that I'll just be using to administer my firewall. Under the advanced options, I could enable service scaling so that I could deploy several instances of the same virtual machine in one go. The instance flavor I'll be using is the basic one required for the Firefly. So right, that's it. That's it for my service template. Now I can create a service instance using that same template. So my service instance is named Firewall as well. I will map the interface 1 to management network, interface 2 to my firewall network, and interface 3 to my internal network. These networks have already been pre-created for me, and this is the internal network designation, and that will be the prefix that it will be using. Right, so my firewall instance is spawning, and while it is spawning, I will go to my MXs and I will be able to see the exact prefixes being advertised through the BGP. So this is my controller number 1 and this is my controller number 2 of cluster 1, and I can see that I'm advertising 4 prefixes. Why do I have 4 prefixes? Because it's one for the management network and another one for the water network. The same happens for the controller number 2 because it's an active redundancy purpose, so they are both advertising it. And this is the eBGP connection towards my MX number 2. The same happens on MX number 2, where I can see the same information about BGP, what I am getting from my for my MX number 1, and that what I am getting from my controllers in the same cluster. While I deploy these type of virtual machines, I will be creating new prefixes for them. They are all /32. I have already created some VRFs in these MXs for the purpose of getting the service chaining functionality delivered through an MX, the internet type of service that I'm looking for. So that is being deployed through the MX, through the gateway from cluster number 2, MX number 2, through the server instance here, and I'll be enabling internet access through this router. Okay, so let me confirm that I have a reachability between water and server. One of the features that Contrail enables you to use is within each cluster, you can specify a DNS server. And with that server, I've already created one. I simply identify that I have a forwarder, and I can create some manual records that are already mapped to some IP addresses beforehand. So I'll be using these addresses to communicate between them. So according to my diagram, water has communication to server, and I would like to see it communicating with an external service. This is a public IP address, and it is resolving OK. What type of service is that? It's a telnet server, so I can just go in and see what it has to offer. We are using here the MX to give us the flavor of service chaining. Okay, so what type of information can I get from this in Contrail? I can go to my virtual router and look at the compute node that is running my water network. So networks here, I can see that this is the compute node I want to see. So getting to the flows, I see that there are a lot of flows going on, or they are about to expire. However, I can see my source port here for the source IP address, sending my Star Wars instance and what type of communication it is exchanging. So I can see some degree of information using the Contrail platform for the flows that are going through my network. I can also see here the routes that are present for my virtual routers within the same within the networks that I have created. So this is the type of analytics that I am able to pull from Contrail regarding either unicast, multicast, or simple layer 2 information between them. The type of interfaces I am creating, and these are dynamic interfaces. They are simple GRE interfaces, and they are running MPLS on top. And this is the label information that I am exchanging between them. Okay, so the same type of information applies to all 4 compute nodes I have. I'm going to skip that process for the time being. What I would like to show before I move on to the actual instance of Firefly that I've just deployed is sticking to this cluster number 1. How can I enable communication between my water and my lava network in one go? Bearing in mind that each instance is running on its own network, and each network is a layer 3 VPN type of instance, I will create a simple routing leak instruction between water and lava. So if I try to go on lava and ping water, I will not be able to ping that instance for the time being. So how can I enable this? I'll simply go to my Contrail platform and I will create under my networks one specific policy that will enable me the communication between the 2 different networks. So water to lava, what type of action do I want is to pass ICMP. Any source network, it's my water network. Direction both ways, destination network, lava, and that's it for the policy. Now I map the same policy to my networks. So I edit the lava network and associate my policy. The same happens for my water network. Associate the policy, and immediately I can see that I have connectivity towards my water appliance. So this is one of the setups that you are able to enable using Contrail in one go with 3 simple instructions. I have access to my firewall instance. So we're using my lava virtual machine. I can now communicate with my server and using enabled protocols that I've pre-configured for the firewall to provide towards the server using network address translation. So I have already enabled SSH towards my server through the firewall. So whenever I SSH my firewall, I go through it and access my server. Right, so I can have all types of features using the Firefly as a virtual firewall and enable security features in front of any other appliance, and that is how the service chaining function is deployed. Thank you very much for your time.